Hi there. Let's take a few minutes and go over your homework assignment. So, questions 7 to 8, 10, 11, 13, and 14. What you're doing, the blue figure is a dilation image of the black figure. So the labeled point here is the center of dilation, and you want to say whether you have an enlargement or a reduction and then find the scale factor. So clearly this triangle has gotten bigger. Number 7 is an enlargement. So to find the scale factor, you go from the center of dilation out to your new point. That distance is 6. And you divide by the corresponding distance. The center of dilation to the original point would have been 4. So that scale factor is 3/2. In number 8, this is also an enlargement, so don't think too hard. So this is 9 units long. Correspondingly, we started with something that was 3 units long, so in number 8, the scale factor is 3. 9/3. In number 10, here's the center of dilation. So we have in number 10, if I look at the original figure, give me just a second. So the blue figure is this one. The bigger figure is black. The blue figure is the small one. So in this case, we have a reduction. So notice the new figure is only 2 units long, whereas the original figure that we started with was 1, 2, 3, 4, 5, 6 units long. So this is a reduction, and the scale factor is 1/3. Number 11 is also a reduction. So what's interesting here is the center of dilation at L. So the new distance from L to a point on the blue figure, that would be 1 unit long there. So if I want to compare that to the original distance to the corresponding point, here's the center of dilation. We would have gone to here, that is 3. So again, in number 11, we have a reduction. That scale factor is, once again, 1/3. So in number 13, here is the blue figure and the black figure. So this is an this is the black figure and the blue figure. So this is also a reduction. So the center of dilation is just the origin. So all you have to do to find the reduction is, in the blue figure, look at the distance here. Let's call it 2 units. So the corresponding length in the black figure is 4 units. So the scale factor here is 1/2. We have a reduction with a scale factor of 1/2. In number 14, inside we have the black figure. Outside, we have the blue figure, so this is an enlargement. So something that would be really convenient to do here is look for a measurement that you can count. So look for a vertical segment or a horizontal segment. So when I look at this, on the blue figure, here is a vertical segment that is 1, 2, 3, 4 units long on the new figure. That would be on the image. On the pre-image, on the original figure, we had a distance of 2 units. So this looks like an enlargement, which has a scale factor of 2. Now, I can also see measuring distances from the origin. I could start at the center of dilation, which is the origin, and all I have to do is measure any 2 corresponding distances. So look, same thing here. From this point to the origin is 3 units long. From the corresponding point here to the origin, that's only 1.5 units long. Well, notice 3 divided by 1.5, you get the same thing. You get a scale factor of 2. It was just simpler to find either a horizontal segment or a vertical segment that I could use as a basis for comparison. So just to review here, number 7, this is an enlargement. The scale factor is 3/2. Number 8, this is an enlargement. The scale factor is 3. 10 and 11, these are both reductions, and they each have the same scale factor, 1/3 and 1/3. Number 13, this is a reduction with a scale factor of 1/2. And number 14, this is an enlargement with a scale factor of 2. So let's take a look at the last two questions, because here you had to do some graphing. So here is the original figure in question number 37, and this is the pre-image. Your job is to graph the image for a dilation centered at 0, 0. So, and we want to use the given scale factor. The scale factor here was 3. So please don't work too hard. Literally, we can take, because the center of dilation is at 0, 0, we can find all of the new points by just taking each x and y coordinate and multiplying by the scale factor. The scale factor is 3. So the new location of M is going to be at 3, 9. 1, 2, 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. Here is M prime at 3, 9. Negative 3, 3. If I multiply both of those by 3, I get negative 9, 9. There's negative 9. There we go. So there's the location of N prime at negative 9, 9. So negative 5, 3 is going to become negative 15, negative 9. 11, 12, 13, 14, negative 15. Negative 9. There we go. That's P prime at negative 15, negative 9. And then last, we have Q. That will be at negative 3, negative 9. Negative 3. Negative 9. Here is Q prime. Very good. So I'll use my ruler. Here we go. Here is the new figure. Clearly it is an enlargement, and it should be, because the scale factor is larger than 1. The scale factor is 3. And because the center of dilation was the origin, it's really simple to find the ordered pairs for the enlarged figure. I'm literally just using that scale factor of 3 and tripling each x and y coordinate. There you go. So last up then, let's look at a reduction. So here is question number 38. So here is my original figure. So the scale factor is 1/4. So literally, to find all of my points, I'm going to take everything and I'm going to multiply by 1/4. So I'm going to write them over here. M, 2 times 1/4. 2/4 is 1/2. 6 times 1/4. 6 over 4 would be 3/2. So there is the new location of M. The new location of N, N prime, negative 4 times 1/4, that would be negative 1. And 10 times 1/4, 10 over 4 would reduce to 5/2. P is at negative 4, negative 8, so P prime, negative 4 times 1/4 would put me at negative 1. Negative 8 times 1/4 would put me at negative 2. And then last, to get the image of Q at Q prime, negative 2 times 1/4, that would give me negative 1/2. And negative 12 times 1/4 would give me negative 3. So all I have to do is plot these points, and I will see my reduction with my scale factor of 1/4. So 1/2 and 3/2 is 1.5. So here's 1/2, and here's 1.5. Here is M prime. N prime is at negative 1 and 5/2. 5/2 is 2.5. So there is N prime. P is at negative 1, negative 2. There's P prime. And then Q prime is at negative 1/2, negative 3. Negative 1/2, negative 1, negative 2, negative 3. There is the location of Q prime. So very carefully then, I can draw the sides of my quadrilateral, and I will have my reduction. And that just about does it. There you go. A reduction by a scale factor of 1/4.